Good morning, everyone. This is a technical breakdown of our code as well as a demonstration of how it works. In our first section here, we have our configuration. This defines our file paths that are for storing generated log data and the blockchain ledger. It initializes a fixed set of users and actions that simulate realistic enterprise activities. We next have the data collection section. This will simulate a synthetic log entries that will mimic real user behavior. We use an Ali distribution that will use a weighted probability array to reflect typical work hours versus off hours. Each of these log entries will contain a realistic timestamp within the past day, a user ID that is randomly selected, an action, and some random IP addresses to simulate what it would be like in a real world situation. We append all of these newly generated logs to the log.csv file. If the file doesn't exist, it will create a new one. It will update all the logs that exist, which is everything that happens at a specific timestamp. Then we have the data normalization section. So what this does is it ensures that all of the required columns will exist within the data frame, and it converts any timestamp column to proper datetime objects. It will extract hour and date components for feature calculations that will happen in the next section. In feature extraction, what we do is we aggregate user activities to produce these behavioral features. And the behavioral features in specific are total actions, unique IPs, mean hour, and STD hour, this is the statistical behavior over time. This will be our count of our distinct IPs per user, and this will be the total events that occur per user. The additional derived features are for any additional issues that could occur, which is mostly VPN connects, fail login attempts, and downloads. VPN connects are usually a huge red flag. So anomaly detection is what this does is we first perform a rule-based detection first, and these are the common rules that we have taken up here. And once these rule-based detections are done, then we will apply an isolation forest model. What this does is it will identify these statistically anomalous behaviors across all of the features, and it will return these anomalies as a tuple. And this tuple it will consist the user, the reason, and the severity. I will demonstrate this in the working of the code. Then the blockchain ledger. So we create a SHA-256 hash of these given data objects for integrity, and it ensures that it's a robust system. And we append all of these entries to the ledger. And what this does is it will first compute the hash of the new entry, and it will link it to the previous hash. Then it will write the updated ledger back to the disk, and what this does is it creates an immutable trail of all the detected anomalies for any analysis that is required later. Then load ledger. This will safely load the ledger file, and it will handle any of these JSON file errors that occur. Then we have the dashboard. This is what the user will be able to see. This UI will provide a live visualization and inspection of the entire pipeline of the code here. And so I will just run the code and I will demonstrate how it works. Okay, so this first section here is our recent logs. This section displays the latest incoming logs. It simulates real user activity. Each of these entries will include a timestamp, a user action, IP, and resource accessed. So what this does is it simulates a real world situation where a user is accessing some kind of system. Then you have user activity features. So here we can observe these aggregated behavioral metrics for each of the users. This will include the total actions, the unique IPs, and the activity patterns by the hour. And it will count any of these events for sensitive events. It will count it here. So these features are the basis for our anomaly detection. Then the detected anomalies. So this section will show these anomalies that are flagged by our rule-based checks as well as the isolation forest model. Each of these anomalies will be associated with a user. So for any user, and it will have a reason as well as the severity level. So this lets us distinguish between normal behavior and potentially malicious behavior. Yeah. After this is done, what it does is it stores all of these anomalies inside a blockchain ledger. And these blockchain ledgers, they are immutably logged inside here. And each of these entries are cryptographically hashed to the previous one. So this ensures that it cannot be tampered with. Finally, we have our user activity over time. This chart will summarize, this graph will summarize the total anomalies triggered per user. So it will quickly help us identify which accounts are showing the most abnormal behavior. This can be changed to any kind of graph. It can be changed to a bar graph. But mostly we have picked user activity over time to show us the cumulative logs that occur over entries and a specific timestamp. So thank you.